On to question 2. Range anxiety is the worry that EV drivers have about how long their battery charge will last. A car manufacturer claimed that its EV was able to travel 265 kilometers on one full charge. Dan, an EV owner, recorded the distance that his car traveled after each charge and found it could be modeled by a normal distribution with a mean of 253 kilometers and a standard deviation of 18 kilometers. So question does explicitly state normal distribution. Typically they will in the exam as well. Find the probability that Dan's EV will travel between 253 and 278 kilometers. So a place to start with any normal distribution question is to sketch a bell curve and add the information that we know. So we want to visualize what we are trying to find. So the mean is 253. So between 253 and 278. The 278 is more than 253. So we want the probability is between 253 and 278. So that is that shaded probability there. So if we're going to do this by hand, which if you don't have a graphics calculator, then you'll need to do, you need to start by working out the z-score, which we can do using this formula that will be on your formula sheet. Z equals x minus mu over sigma. So the z-score equals your x value minus the mean divided by the standard deviation. That will find us a z-score that we can then use to find the probability using that table there. So z equals x. So 278 minus the mean 253 divided by the standard deviation of 18. So put that into the calculator and we'll work out what the z-score is. It is 1.389. Positive because we are on the right hand side of the bell curve. So we'll go to the z tables and find where a z-score of 1.389 is. So 1.389. So 1.38 is 0.4162 plus the difference is 14. So we'll go 0.4162 plus 0.0014, and that gives a probability of 0.4176. It's absolutely fine to leave that as a decimal. If you want to do that on your graphics calculator, then go menu and then stat, then distribution, normal NCD. Then we go for a lower limit of 253, upper limit of 278, standard deviation 18, and mean 253, and press EXE, and that gives you 0.41756673, which will round to 0.4176, the same answer. So that is an achieved question. Find the probability that Dan's EV will travel less than 260 kilometers on one charge. So again, I'm going to start by sketching a bell curve. These don't have to be perfect, it's just for your own benefit so that you can visualize what is happening. So the mean is still 253. Standard deviation is still 18. So 260 is going to be on this side. It's more than the mean. So we want the probability it's less than 260. So that would be this area here plus this orange shaded area. Well, that orange shaded area is the entirety of the left-hand side of the bell curve. So that's going to be 0.5. So we'll add that onto the other area. So similar process. So we know the mean, we know x, we know sigma, so we can work out a z-score and then calculate that probability in the z tables, and then we'll be able to add 0.5 and get the answer. So z equals x minus the mean divided by the standard deviation, which is 18, which is 0.389. Again, that's positive because our x value is bigger than the mean, so we find 0.389 over here, so 0.389, so that's 0.148 plus the difference is 34, so that's 0.034, 0034. And that is a probability then of 0.1514. So that is this probability here. So then we need to add 0.5 to that to get the probability that it's less than 260. Which would be 0.6514. Now, as you might expect, it'll be a bit quicker to do that on the graphics calculator. So if we go to stat, then distribution, then normal, then NCD. So we'll make our lower 0 and our upper 260. So this is going to work out the probability that the range is between 0 and 260, so less than 260. Standard deviation and mean are unchanged, and you get 0.6513 if you do it on the calculator. So either of those would be accepted. They'd be absolutely fine. For both of those, this question and the previous one, those achieved questions, you just need to have the correct answer. No working is required. If you're doing it by hand, then you need the working, of course. And with any null distribution question, always sketch your bell curve. Okay, for the next part, 5% of the time Dan is unsatisfied with how far his car goes. So what that tells us is 5% of the time, the lowest 5% is not far enough. For Dan to be satisfied, what's the minimum distance his car will have to travel? So you see I've sketched a bell curve here, and I've added that purple probability 0.05. Now, because on the Z tables, if we take a look, it actually shows us that the probability is always calculated from the mean going outwards. That's why I've calculated that orange probability 0.45, so 0.5 take away 0.05. And from the Z tables, that corresponds to a Z score of 1.645. But we are on the left-hand side of the bell curve. Anything on the left-hand side has a negative Z score. So that is negative 1.645. And that's very important for when we substitute all of these numbers into the Z formula, because our answer will just not come out right if it's not negative. So x, we don't know that. Minus the mean, we do know that. Divided by standard deviation, which we also know. So our objective here is now to solve for x, which means get x by itself. So move the 18 and the 253 away from it till it's by itself on that side of the equal sign. So I'll start off by multiplying both sides by 18 to get rid of the fraction. It's always the first thing we want to do. So negative 29.61 equals x minus 253. Now that's minus 253, so we'll add 253 to both sides. And that gives 223.39 equals x. So the minimum distance will be 223. You could have put the 0.39, we'll put the 0.39 kilometers. Be okay to round that to 223. So this is a merit question. For a merit or higher question, you need to show some sort of working. If you just have the correct answer, then that would be an achieved. For merit, correct minimum value obtained with working and or a diagram. So if you draw yourself a bell curve diagram like this, that would be sufficient. To do this on a calculator, so we'll go menu, stat, distribution, normal. Now we're going to use inverse normal. Tail will be the left tail, because we work on the left hand side, and you can put the area 0.05. Give the standard deviation and the mean, and that gives you 223.39, the same answer as what we got here. So you notice we could use the 0.05 on the calculator, we didn't have to put the 0.45 in. So long as you set the tail to the left. Okay, so that was that question. Let's go on to question B. The same car manufacturer released a new EV. A new owner of this EV found that 28% of the distances were more than 350 kilometers. Calculate an estimate for the mean. Assume that the distances traveled can be modeled by a normal distribution with a standard deviation of 18. Okay, so we know the standard deviation is 18. We've been given a probability, so 0.28. We've got an x value. We don't know the mean. As always, start by sketching a bell curve. Mean in the middle, which we don't know. So the probability that's more than 350 kilometers is 0.28. So that's less than a half, which tells us it must be over here somewhere. It must be on the right hand side. So the probability is 0.28. So that's this probability here. So that is 350. So that means that this probability here must be 0.22. So notice my diagram is not amazingly accurate, but that's okay. It's accurate enough. Because it's really just there to help visualize what we need to do, what we need to calculate. So to calculate the mean, it's going to be kind of similar process to the previous question. We need to find the z-score that corresponds to this the orange probability, 0.22. Because again, z-scores in the z-table always measured from the center, from the mean outwards. So we'll go and find a probability of 0.22, or as close to it as we can get. So that is here. That's as close as we can get without going over. And then if we go for a distance 10, perfect. So that's 0.583. 0.583. This will be positive because we are on the right hand side of the mean. So we can now use that to calculate the mean. So let's substitute everything we know into the equation. So 350, take away the mean over 18, and we'll go through the process to solve for the mean. So multiply both sides by 18. So again, get rid of that fraction first by multiplying by its denominator. So 10.494. Then take away 350 from both sides. And then just make both sides positive. We'll just round that to one decimal place. So the mean is 339.5 kilometers. I'm going to just add kilometers there. So that is the mean. And that is another, well, that's an excellence question. For achieved, correct answer only, or you found the z-score. So an achieved would be getting to here. For merit, correct z value used, but the mean is incorrect. So something went wrong in this calculation here. And for excellence, correct mean found with evidence of your working. You'd have to show evidence of your working because this is one that you wouldn't be able to answer on your graphics calculator. You can use your graphics calculator and specifically use the solver function. If you get a bit stuck here, you can put this into the solving function and work it out that way. But you can't use the null distribution functions to get that answer. Right, on to the last part of question 2. If you want to have a read of the question, pause the video now, because I'm going to move on. And have a good look at this graph. I will leave some of that on the screen, but I'll have to scroll down fairly quickly. So we need to compare the shape, center, and spread. So let's start off with the center. So we can say that the mean is similar. So 300 in the model compared to around 300 to 310 here. We could also say that if you add up these ones here, that 24 out of 50, so 0.48, 48% of the values of the data is below 300. So 300 is here, which is why I included that bar there. So this means that the median must be close to 300, but it will be slightly higher. Which means that the claim could be valid, because that was what was said, that the median was 300, so a claim could be valid. Okay, so that's center. We'll color code these. So we'll do spread a different color. So one point we can make is the data has a range of 90. So range is maximum minus minimum. And what that means is the standard deviation is around about 15 kilometers, which is what the model standard deviation is. So because remember, in a normal distribution, almost all, so around 99% of the data is within 3 standard deviations either side of the mean. So 6 standard deviations in total. 90 divided by 6 is 15. Also, we could say, well, yep, the standard deviation is 15. So for standard deviation of 15. So if we're going plus or minus 3 standard deviations either side of the mean, that gives an approximate range of 255 kilometers to 345 kilometers, similar to the experimental range, but it's slightly less than the experimental range. If we move on and talk about shape, Well, a normal distribution is symmetrical about its mean. But this isn't. This data is left skewed, meaning the left tail is longer. And it's also not a bell-shaped distribution like a normal distribution should be. And what that means is the mean, median, and mode are not all the same. So normal distribution is not valid because the peak is not in the center. So normal distribution not valid because the peak is not in the center. You could calculate a probability and sort of just prove the skew in the data if you wanted to. Also, this is not clearly unimodal. Whereas a normal distribution has a clear peak. So one bar should be sort of clearly higher than the others, rather than just only slightly, like in this one. Okay, so let's give an evaluation. That's what we need to do. So we can say that the mean is close, it's pretty similar, and standard deviation is the same, but the shape doesn't match. So the claim is not fair. So the mean and standard deviation are close, but the shape it's not a normal distribution shape. Not a normal distribution shape. So the claim is not fair. In terms of the data collection, this test data in this distribution that we were shown was only collected in urban areas. Now that could be problematic because the speed, the type of driving affects the range not just of EVs but of any car. It affects economy, efficiency, so that could have an impact. We don't know if that's how the manufacturer did their tests. They may have used data from a range of conditions rather than just in urban areas. Now what that means is that doesn't mean that this data conclusively shows that the claim was not fair, because it could have been collected in a different way. So the manufacturer may have used data from a range of conditions. So it's possible the claim is still correct, despite what this distribution shows. So as you might guess from the amount of writing we've done, this is an excellence question. For achieved, 2 valid comments, so really any of these 2 points, about different aspects of the shape, center, spread, or a comment on the quality of the testing. For merit, 2 valid comparative comments, so comparing this distribution to the theoretical distribution with justification. For excellence, all of that, and a clear and explicit evaluation of the manufacturer's claim, so you need to have at least one of these points in the red writing for excellence. So that concludes question 2.